peak positions in carbon-13 NMR are spread over a much larger range than they are in proton NMR. This is because carbon-13 experiences all the electronic effect directly, while proton experiences them only indirectly over carbon. So for proton, our useful NMR range was between 0 and 12 ppm. However, for carbon, this range is about 20 times larger, between 0 and 250 ppm. This large range means that we will very rarely have non-equivalent carbons overlapping in carbon-13, while in proton NMR spectrum, that was a relatively common phenomenon. Even though some protons might have been non-equivalent, if their difference is not overly large, they will overlap. In carbon-13, that is very rare. Let's look at some of the ranges for the different sizes of compounds. Again, this will be given to you as a table on your exams, but this is general guidance. Carbonyls are typically the ones that absorb at highest ppm values, followed by aromatics, alkenes, alkynes, which are lower, carbons attached to all groups like ethers or alcohols, and finally alkanes, which are at lowest ppm values. Yeah. So you can see that these correlate relatively well with corresponding proton absorptions, except that they are spread over a much larger range. Another important feature of carbon NMR spectra and proton NMR spectra as well is that proton NMR spectra are recorded in deuterated solvents. Deuterated solvents are relatively readily available. They are a little expensive, but they can be made. And the most common one is deuterated chloroform or deuterated water. And so in proton NMR spectra, these solvent protons are invisible. Generating a solvent which has no carbon-13 is quite difficult because you would need to use the carbon-12 enriched solvent, and those solvents are very expensive. And so most commonly 13C NMR spectra are recording the same solvent, the same ones, which means that we will see the solvent peak. So if you look at our typical carbon-13 spectrum, we will see several peaks. And then if we record this in chloroform, which is the most common one, we will see a triplet centered around 77 ppm. This always comes from chloroform. So do not make a mistake of interpreting this as coming from your compound. Again, and this is the final point, is that TMS is used as a standard in carbon-13 NMR as well, and centered at 0 ppm. So the same compound is the standard at 0 for both carbon and proton NMR.